We've been talking about writing testable questions and then turning those testable questions into hypotheses or educated predictions of what will happen. Today, we are going to be using a pretty magical water bottle here to practice writing strong hypotheses. So first, I want to investigate. I have a water bottle and it has 3 holes in it, but I have covered them all with tape. If we uncover one piece of tape so that we have 1 hole in this bottle, then how many holes do you think water will shoot out of? Let's think about this. I've written a testable question. If I add 1 hole to a bottle, how many holes will water shoot out of? First, we want to look in every testable question for a piece that we are going to change. The change that I see in this question is we're going to add 1 hole. We've been practicing circling the thing that is what we change. Here we could circle add 1 hole, and that's the change we want to make. Then we want to observe something. What we're going to observe here is how many holes will water shoot out of. That's the piece we practiced underlining. What I want to do now is transform this testable question into a strong hypothesis. Remember, a hypothesis should be written in an if-then statement. If I make this change, then I should observe this. So let's practice with this. If 1 hole is added to a bottle, then what? How can I finish this hypothesis? What do you hypothesize will happen if I uncover 1 hole? Yes.
Ooh.
What do you hypothesize?
If 1 hole has been added to a bottle, then nothing will happen. That's my hypothesis.
Nothing.
Nothing.
Are you brave enough to come sit underneath it while we uncover this hole?
Brave is my middle name.
Excellent. All right, everybody, so we've hypothesized if 1 hole is added to a bottle, then nothing will happen. Are you ready? On your mark.
Wait. Maybe,
Yes, brave?
Maybe I'm not so sure. Hold on a second.
So convenient that you have that today.
Can't get it open.
Cut to when you're all the way ready. I can't write on my smartboard.
Keep filming. Why won't it open? Oh, there.
Oh,
I
it
wasn't
won't
pushing it hard enough. Okay, all right. All right. Now I'm ready.
You're ready now? All right. On the count of 3. 1, 2, 3. It's sprinkled out a bit, but now no water is shooting out at all. There is an open hole here, and unless I squish it or spill it, nothing is coming out. All right, let's return to our hypothesis. We hypothesized that if 1 hole was added to the bottle, then nothing would happen. Was our hypothesis supported or not?
I was definitely right.
You were right.
I was right.
A little dribble, but then nothing continued shooting out like we expected. So yes, this hypothesis was supported. Let's practice again. So remember, this water bottle has several covered holes. If I want to uncover another hole or add 2 holes to this bottle, what do we hypothesize is going to happen? So my testable question is, if I add 2 holes, that's my change, how many holes will water shoot out of? That's what I want to observe. Let's turn this into an if-then statement.
I'm thinking, based on what happened last time, that this time, if you uncover the first 2 holes, then water's going to shoot out of the top hole, but not the bottom hole. So I hypothesize if 2 holes are added to the bottle, then water's going to shoot out of the top one, not the bottom one. Yeah, that's my hypothesis.
All right, so we've got a hypothesis. statement. Let's test it. All right, first I'm gonna uncover the first hole again. Nothing happens, and now I'm gonna uncover the second. Let's look. We can see air bubbles traveling in the top hole, and we can see water shooting out of the second hole. So there is not anything shooting out of the first hole, but there is water shooting out of the bottom hole. Let's cover that back up and think about our hypothesis. We hypothesized that if we have two holes, water will only flow out of the top hole. Is that what we observed?
Not this time.
Not this
I was
time.
wrong.
Sometimes our hypotheses are not supported, but that doesn't mean we're bad scientists. That means we learned something. We learned that water was going to flow out of the bottom hole, and that prompts us to ask some more questions. That's what science always does. It's just a continuous series of questions. So let's ask one more. If I add 3 holes to a bottle, how many holes will water shoot out of? What do you think?
I think I learned my lesson. So in the first attempt, nothing came out of the top hole. On the second attempt, I was wrong. Still nothing came out of the top hole, but water did come out of the second hole. So this time, based on my previous experiences, I'm gonna say nothing's gonna come out of that top hole, but I do think water's gonna shoot out of the second and third holes. So that's my hypothesis. If we add 3 holes to the bottle, then water will shoot out of the bottom 2 holes.
All right, I love that hypothesis. I especially love that you used research and your previous experiences to write this hypothesis. It's not a guess. Scientists don't guess. Let's see what happens. First hole revealed. The second hole. And the third hole. Check that out. Nothing's coming out of the top hole, just like she hypothesized, but water is shooting out both the second and the third hole. Great job in today's lesson. Thank you, Mrs. Long, for being such a brave volunteer. On Monday, we will continue researching testable questions, turning them into hypotheses, and continue learning about the scientific method.